The overall goal of the following experiment is to improve the settling time of severely underdamped electrostatic fringing field microelectromechanical system actuators. This is achieved by microfabrication of the electrostatic MEMS actuator. As a second step, the substrate beneath the actuator is selectively etched, which significantly reduces squeeze film damping and enhances the severely underdamped conditions. Next, dynamic biasing waveforms are employed in real time in order to determine the optimum waveform parameters for fast settling time. Results are obtained that show significant switching time improvement based on comparison to typical unit step biasing.
Though the method is used to improve the switching time of electrostatic fringing field actuators, it also can be applied to fields like micrometrology to extract thin film parameters like Young's modulus, Poisson's ratio, and biaxial tensile stress.
The first step in fabricating the electrostatic fringing field MEMS beams is UV lithography. Begin with a properly cleaned, oxidized, low-resistivity silicon substrate 25 mm by 50 mm and 0.5 mm thick. In this video, schematic depictions of the substrate cross-section and top view will show the progress of the fabrication. Place the substrate on the chuck of a photoresist spinner. Spin coat hexamethyl disilazane and then positive photoresist each at 3500 RPM for 30 seconds. Transfer the sample to a hot plate set at 105 degrees Celsius and soft bake the photoresist for 90 seconds. This is the schematic view of the sample at this point. Once this is done, move the sample to a mask.